My name is Tyler Maurer. Been working in AI for over 5 years now. We have a startup called WebAI, and really came together to kind of like let you know shared learnings were what we've experienced in the field. It can really be summarized by one phrase that AI is a team sport. Before I go too far into it, I want to let you guys know that the other co-founder and CEO, David, is going to be speaking at 2. He's going to be speaking on moonshots more historically, and then some of the challenges we have to overcome later to be able to really kind of fully utilize and capture the value of AI. So my name is Tyler, one of the 3 co-founders. You can see me on the right. In the middle is David. On the left is Ethan. He is the most introverted of us, which means that he is currently in a basement working on a computer. And then we were sent out to be social. So it's great to be here and meet you guys today. We started the company in 2019, which is pretty old for an AI company. Most companies now are founded in 2022 to 2024, post ChatGPT. So we've been involved in the space for quite a while. I've worked at 5 different startups. One of them was a nonprofit. Unfortunately, it's not the one that you're thinking of when I mention an AI in startups. And I have a history in distributed and AR/VR. And I live in Austin. I have a wife for 8 years, so wouldn't be able to do it without her. We started the company with a $450 loan and a Mac Mini. So when we built the company, we're really focused on solving the problem of AI, which is how do we actually make AI accessible? How do we manage the life cycle of it? And most of you will know that AI is traditionally a cloud service. And so when we're looking at using AI, it's really more of an integration effort than it is actually an exercise of owning the data, creating the models, training them, putting them into deployment, and making them accessible. So our Mac Mini startup was an i3, and it was really a way of saying, if this is the lowest common denominator of hardware we want to support, how do we have to approach the lifecycle management of AI? And we're working on democratizing access to the infrastructure for AI, in addition to allowing people to create discrete AI model experts. And so right now, what you'll see is that you have a very large model like a ChatGPT, which can only run on cloud. And because of that, they have requirements of petabytes of data to be able to actually create the model. They need millions of dollars of compute, upwards of 100 million is what they're training now, to be able to train them. And so our purpose is, how do we allow people that don't have hundreds of millions of dollars of access, compute, or petabytes of data to actually engage in this without being stuck being on a cloud service like an AWS or an Azure. On the top right is a download for the platform. And so you can go to our website, you can download it and use it. Unfortunately, it is only on macOS right now. So if you're cool and you have a MacBook, you can use it. If you have a Windows, hopefully your computer didn't go out when we had issues with CloudStrike. Our thesis has really kind of evolved over time. And when you're looking at using AI, it's really kind of, you can boil it down into a statement that one size really fits none. How many of you guys have tried to use AI and find that you need to alter it quite a bit to actually get it to work for your use case? Most of you guys? What we realized is that 5 years ago, we're really focused on computer vision. And the task of computer vision is, how do you actually get things to recognize things like humans? And what that means is you have to go through a process of bringing data in, creating data sets, and then training those models to actually get them to work with your solutions now. But with patterns like API-based, like ChatGPTs or Claude, people think that it's a lot easier to apply AI than it actually is. And it requires a lot more hand-holding to get it over the line. So what we allow people to do is to run models like ChatGPT on their infrastructure. And so we have a distributed backend. We allow them to customize it, and we have an interface that allows people that don't have programming background or ML background to interact with it. And then ultimately, because it runs on their own infrastructure, they don't have to worry about any privacy concerns. So with that, I'll kind of go into, like the founding of the company and some of the lessons that you learn is really when you look at going into local AI, there's different problem sets and things that you need to have to get that deployed. And these are often hurdles that you have to overcome to start experimenting with it, to get it deployed and actually engaged in your environment. So you have to train models, which means you need data. You have to have an ML engineer, and you ultimately have to have a budget as well to be able to run that experiment. After you have that set up, you need to be able to run inference on that. And that means that you have to have the hardware provision to be able to run it, whether that's cloud or that's a local computer. And then you need to have a budget and a team to take that body, that AI, and then actually be able to extract the value of it. So you can imagine an AI model by itself is not very valuable. The thing that makes an AI model valuable is the data that goes into it and then the transformation that comes out of it. And so how do you get the data into it? How do you get the data out of it? And then how do you make sure that that's operating in an environment that actually solves your business problem? And then finally, once you have those two together, you have to be able to orchestrate it on your hardware. And with cloud, you can just kind of hit play, and it runs, and it scales, and it will do everything you need to. But when you're provisioning hardware and you're using compute that you've already built out, it's a different exercise. Because now if I'm using, say, like my laptop, and I'm contributing it to a local cluster or local group of devices, I have to actually set limits on how my device can contribute compute, the rules around it, and that's a bit of an exercise for the IT team and also like an architect team to get that situated. And then finally, once you have that set up, you have to be able to scale it. So you have your solution working in Ohio. How are you able to bring it to Colorado, Detroit? How are you able to bring that at scale? And that really requires a network engineer, the ability to translate environments to be able to make it where it's not cloud dependent and it is accessible in local environments. And so when you're working on something that doesn't have accessibility to Wi-Fi or doesn't have accessibility to the internet, you have to make sure that you can run it in an intranet, then you can actually take that thing and then scale it to other solutions. And so, this is in the space. We've been doing this for over 5 years, and we put that into one environment. And the reason that this is important is because you have all of these different buyers in different minds that are coming to you when you're actually working with AI. You have the board, which is saying you need to apply AI. You have an executive team, which is then pressured to get everyone to orchestrate it and to use it. And then you have the team actually responsible for provisioning it, managing it, getting it spun up. And these people are often the ones that are looking to put it into the product, but they're also the ones that are users of AI as well. And what we found is that the executive team has as many ideas for AI and how it can be applied as the team that's actually on the ground working on getting it facilitated and has hands-on of the problem set. And so being able to put everyone into a conversation and get them to work on these solutions together. So a lot of this starts with prototyping, right? The ability to work with prototyping very quickly. It comes to share of thought. Once you have people who are familiar with the domain space, the capabilities of AI, it's actually very fruitful to have them talk in a room. And what we've noticed is that a lot of people who come up with an idea in AI oftentimes settle on really productionizing their third idea in AI. And the sooner you can start prototyping on it, the sooner you can realize whether or not you want to go through the effort of actually putting that thing into production. And then finally, share of work, right? How do you make it where the sales, like Jim from sales, is able to create with AI, work with it, and then hand it off to the ML team? So your expensive talent that is very constrained is saved for your already vetted solutions that you know that you guys want to work on. And so this is where being able to put everyone into one environment is super important to get them communicating and getting them experimenting together. So I wanted to go through some observations we've seen. So we've had the opportunity to work with Fortune 100 companies in the airline space, in transportation, in warehousing, in brick and mortar, everyone that you can imagine. And the first thing that we run into is a lot of blockers that prohibit AI from being deployed. So I'm going to go put a slide up, and then I want to know how many of these resonate with you guys when you're thinking about applying AI. Do you run into issues where it's very expensive to experiment with, and so there's things that you don't even touch? Right, say there's like you have to get a budget allocated. It's difficult to use. It's very hard to get something spun up and operating properly. You have true AI scientists. There's about 300,000 in the world, and they speak the language of linear statistics and algebra and gradient descents. And that's not everyone's vocabulary. And so it's a real blocker when you're looking at creating AI and actually leveraging it at scale. And one that sticks out a lot is the data exposure for it. And so I think everyone knows that the idea behind AI, the pursuit of AGI, is to actually have it where we are engaging with something that can replace us in some capacity and can do work of share without human capacity. And so people are concerned about working with cloud solutions that are ultimately servicing their competitors as well. And they don't want to give their IP, they don't want to give their knowledge, they don't want to share their information with the same service provider that is then going to train on it and then make that accessible to their competitors. And this is something that we've seen with some of our sister companies in the health wearable space, where they're working with AI and they're working with one of the largest platforms that's available, but they're actually not able to scale with it because they have concerns of sharing personal information. It's health data. You can't share your health data with something that's going to train on it, make it accessible, and share it to others. So do any of these resonate with anyone for blockers with AI in general? If they don't, we should grab dinner or coffee. I would love to understand how you guys don't have any of these problems. And so, it's good to kind of take a step back and actually look at what AI can do. Because right now, there's a huge focus on generative AI, and really thinking that, the one thing that we're looking to do is get a chatbot up, which is fantastic, but that is a fraction of what AI is actually capable of. So AI is able to broadly recognize patterns that humans can, whether that's on vision, that's in text, that's in audio, that's in 3D. It's able to learn like a human, and you can train it like a human, which means that can be deployed to anything with a camera. It can be deployed to users' devices, cars, anything. And then it's also able to work. It's able to actually be put to work, and I think, it was the 1997 WWDC event where Steve Jobs was saying they had people in the back who were working on AI agents where you could leave your computer and you come back and it's still productive. And we're finally getting to the point where they can actually do that. So when you look at applying these, the benefits can really be, I would look to summarize them in a different way, right? We have the ability to maintain things. That means that we don't have to take people and put people in positions where they have to check part accuracy. They don't have to read every form submission that comes through a website. We have the ability to automate processes, which means that sometimes you're either adding work requirements to an existing user base, or you're hiring someone to create new processes. And AI allows us to take a step back and say, well, instead of hiring this person, or instead of creating this role, can we actually automate that and apply AI? And that doesn't just have to be text. That can be a lot of different data modalities. And the one that we're most excited about is creation. And creation is really exciting because it's something that we've never seen before. We've never been able to engage in something and see it imitate human intelligence. And while creation is really exciting, I do think it is like the most standardized approach, and each of these are valuable for understanding how you can actually apply AI within your company. I would actually argue that creation, there's a level of patience that's required to be able to take the thing and then actually adapt it to your environment. And so you can think of AI as like a person, right? It's a very talented intern, but you wouldn't want to just take a very talented intern and then have them respond to very important business emails. You'd want to be able to coach it. You'd want to be able to advise it. You'd want to be able to provide it analytics. You'd want to be able to see it perform. And so there's risk with automating the creation process from scratch. And so the reason we're not seeing a lot of the value actually extracted is because we're not applying AI as a whole. We're actually just integrating an API. And this is, there's like two different threads of thought right now. The first thread of thought is AI overhyped? Is it actually able to do the things that we're talking about? And the other group is saying that there's so much more we can get from AI. There's so much more we can do with it. And it really kind of comes from the split with how we're actually approaching it. And the main problem we have is that we're not really using AI, right? We're using a statistical algorithm to reproduce patterns in text. And so our experience of what it can do is fairly limited based on our level of engagement with it. And that's not our fault for having those issues. It's a very costly process to engage and to be able to facilitate that share of mind and ultimately work with people in that space. But it's also good to understand that AI has so much more potential than what we're giving it credibility for. And so does anyone have this problem going on right now? So on our right, we have the gentleman who's trying to make something taste better by adding olive oil to a salad. And he's just pouring a chat interface onto it, right? So you got a product and you're applying AI by just adding a chat interface. And now you have chat interfaces for everything, right? It's like if you want to get if you want to manage your Dropbox, there's a chat interface. If you want to go do the most basic thing, there's a chat interface. And some of the most disruptive patterns we're seeing aren't from chat interfaces, but it's actually utilizing AI in the back end to create new types of experiences and new things. And so at its base, what AI can do is it can recognize and it can match and it can reformat and it can draw out patterns that normally you would need a level of human intelligence to do. And when we understand that as a whole, we're able to do much more than just add a chat interface. So I'm curious, is there anyone that would redo their product or their platform with AI now as opposed to just adding a chat interface? Like, would you rethink how you're actually exposing the pattern? Would you rethink how people are interacting with the platform? Or do we really think that the best way to use it is just to put an assistant on it? It's a rough question, but I think that the reason we kind of have this disconnect with AI is because we do think the most valuable thing we can do is have it talk to a website or have it talk to a database. And because of that, our expectations and our experience have been somewhat constrained to one fixed pattern. So we have I'm going to go through some use cases of people we've worked with in the field that are working with AI more cohesively. And that are really getting to enjoy the fruits of AI outside of just a traditional interface. So this is one of our favorite examples where we're working with an individual who is not an AI scientist. He's not a software engineer. He's actually a line worker at a warehouse. And when he was given the proper tooling, he was able to train AI models. He was able to push them into production and prototype. And within a month, he was able to come up with 4 different applied AI use cases, actually meeting a corporate KPI that a team of 30 AI engineers couldn't do previously. And they had I'm not actually using the footage from the warehouse because that's their information, but they're deployed in warehousing. And in their situation, they had it where there's miles of conveyor belts. And one of the issues with getting fire detection in these giant warehouses is that the air density is very low. Because you have such a wide amount of space, it's very hard to get the proper amount of O2 to actually read that there's a fire. So there was a carburetor that was in a box flying around these miles of conveyor belts. It was just on fire. And they didn't know that it was on fire. It's a very automated warehouse, and so they just had fire like flying around, hitting stuff in the warehouse. But because he was able to tap into his security feeds, and he was able to get exposure to the data, he was actually able to deploy a fire detection system based on the infrastructure they already had and get a level of security that they hadn't before, which is just a really good example of people that you wouldn't think having the right ideas, being able to take what they have and apply it at scale. He actually got a promotion because of that, which is pretty cool. This is another use case, which is we did in airlines, but I'm using footage from a train from Amtrak. But in this use case, we had a customer use the platform to actually get Edge AI working in an environment where they were able to track and train all sorts of different fun models. So their goal was, how do we unlock better turn times, which if they can get more flights per month is a $100 million problem per year. And the level of insight that they needed was, how are the staff engaging? How are the customers engaging? When does the plane arrive? When does the plane start deplane? When does it start enplaning? And how do we increase those efficiencies? So they were doing everything from pilot detection to trash detection to wheelchair detection. And they just bought a couple Macs from Best Buy, and they went and they put it in a closet. And they were able to get insights that they wouldn't have been able to earlier by just spinning up these algorithms and getting them deployed. And they were running an A/B comparison with a cloud provider, and the other experience was actually quite different. They had to go provision servers, and they had to get these very expensive, very loud, very costly servers, install them in a closet, and then they had to go through this whole engagement where they're running the same solution, but with 50 grand in hardware as opposed to 8 grand in hardware. And it was very loud, and it was very expensive. So it's another really good use case of AI being applied, not in a way that you would think of, but in a way that actually solves a real value and unlocks a lot of cool insights for these companies. So if computer vision, if you haven't thought about it, broadly speaking, if you have any physical infrastructure, if you have anything with a camera, if you have anything with an employee, there is something you can do with computer vision. You can do a lot at scale, and it's worth prototyping sooner than later. They came to us for a separate. They wanted to work on a separate use case, but they ended up finalizing on this one because the value was so large. And now they're scaling that exact same infrastructure to do many more things. Here's another fun example, and a fun detail on the platform is it actually combines compute to run these models. So in this case, you can see I'm a little sad in the background because David is actually using my compute to run the AI model, and so he's running a model directly on my device, and he's using it in the headset. And this is a use case that we're working on with a online educator. And what the online educator is doing is a pattern that they couldn't really do if they were traditionally on cloud. They're going to deploy large language models for education without having to pay the cloud costs for it. And they're doing that by using their hardware to train the models, and then they're also doing that by running the models on the students' devices when they're actually finished. And you can imagine that the cost of 300,000, 600,000 users constantly using an API endpoint to run a large language model would be very costly, and it's very prohibitive for education. But in this case, we're actually giving them the infrastructure to run it at zero cost. And so it's a very different interactive paradigm that they wouldn't have had otherwise. And they're working, what they're doing is they're training three different models. One that is fine-tuned on creating coursework, which is taking their traditional data, and it's actually learning from that to be able to replicate those patterns. And the other one is working directly with the teachers to be able to understand what they want to do, how to interact with with their students, and be able to accelerate the process. And the final one's actually a tutor, and they're training a model to tutor the students. And so there's three different users of the AI, but because they're able to train it, because they're able to run it locally, they don't have to worry about data exposure, they don't have to worry about costs, and they're actually able to get these models and own them and not be stuck in an ecosystem that they have to pay a fortune for over the long tail. So this is a really exciting one, and we're seeing a lot of people engage here as well. If I was going to ask for a raise of hands, how many of you guys have only thought about using AI in the cloud? There's a few. And so what I would challenge is there's a perspective that I think is helpful is if we're going to run AI in the cloud, it's almost like saying we should run gaming in the cloud. And putting gaming back into the cloud is just unfeasible for a lot of different solutions. And you can't have self-driving cars running via latency of the cloud. It has to be local. And when you actually bring your solutions locally, you're able to solve problems that you couldn't have earlier, which is really, really powerful. So as you're thinking through AI, I would encourage you to look beyond what is traditional. And there's a lot of these things that are actually working, even on mobile devices, that are far more capable than you would think that you'd have to use an API for. So if anyone is here, because startup was a hashtag on this session, a couple takeaways on being a startup. I'll start at the bottom. You probably shouldn't start one. They're not for everyone, and they take a lot of work, right? So the caveat to that is it's one of the most rewarding things that you can do. So if you actually want to do a startup, I would highly encourage it if you are the right person for it. But understanding that you're going to work a lot of 80-hour weeks, 90-hour weeks, and it's going to take 5 to 10 years to get running properly. Work with people you enjoy working with. You're going to see them more than you see your family. And you want to be around people that are going to lift you up, that are going to work with you, and you're going to ultimately fall asleep on a couch with trying to get the thing to work for a demo. Another one would be you're going to have a lot of shared overlap with ideas. I know this is very finicky in the science space, right? This is why we cite authors, we cite contributors, we cite editors. Understanding that there's going to be a lot of shared overlap in ideas, and being able to just acknowledge them for everyone and make it a very inviting environment. Otherwise, when you get people that just want credit for stuff, it becomes very toxic, and it kind of sucks. The last one is you just want to hire people that are smarter than you. So it becomes easier when you have people that are smarter. And then there's a QA slide. Do you guys have any questions, any thoughts that you'd love to ask? Yeah. So let me jump down.
When you want to actually invest, it's not just people, it's the platform. What's your strategy? Or is it like first figure out what the end goal is and then go from there?
Yeah, I would. The question is there a strategy that would recommend for people that want to get started in AI? Do you have to know the use case before you get started or finalize on it? Is that
And then how
correct?
do you go about it within large groups that haven't really dove into AI?
Yeah, and then the follow-up question is, how do you actually do that at a large company? So I think the first thing to understand is that everyone's going to have an idea of what you should do with it, and so and they should have an idea because everyone has a solution that they can actually they can apply it to. And so if you can leverage AI, if the average person can leverage AI to save 15 to 30% of their time, that's a massive productivity boost for the organization. So some of the things that we've seen good success in is having broader conversations around AI, whether that's a kind of like a cooler conversation, like a session where people are talking about it, and then spinning up like small groups, just so people can kind of share their thoughts and pool them, put them into forums. And then I would also, we also recommend that people just start messing with it. So I definitely encourage people messing with it first as opposed to waiting for it, because there's very often someone will come up with 10 different ideas, and because they have 10 different ideas, they don't actually want to start one of them. But I think that the sooner you can go through the pattern of engaging with AI, the sooner you'll be able to work through the kinks, and you'll figure out how you engage with it, and you'll be able to get them deployed. So we traditionally have, the one thing I would look for is like a commonality. What is a use case you can work with that allows you to horizontally expand to solve different problems? And then that will allow you to get a lot of value upfront. Yeah.
I was wondering how does that work to where it's not too slow, but it's giving an accurate answer to the students if they may be using limited hardware?
Yeah, absolutely. So the question is, we worked with AI before. When you run them locally, how do you make sure that they respond fast enough and that they actually provide accurate results on those use cases? So in this area, I would actually, we traditionally, what we do is we work on creating custom models for them, right? So it's an exercise of what data do you have, and then how do you actually fine tune a model for that? Because what you want to do is, these models are very, very powerful. And I'll use an example that David uses often, is that you may be a pilot and you may know how to fly a plane, but that's not something you're thinking about right now, right? You're not thinking about the flight controls, your checklist, or anything like that. You're in a separate part of your brain where you're focused on this conversation, AI, and everything that's really relevant to it. Similar for cooking and all these different things. You have all these talents in these areas that you can engage with that you're choosing not to right now. And the way that AI works is when we're training a generalized model, what we're doing is we're tuning on a very large amount of information, and then every time we interact with it, we're firing the entire thing. So it would be equivalent of your entire brain working all the time, but you're actually just focusing in on one area, and because of that, you're able to operate. But you can't comprehend everything that you know all at once. But that's what AI is doing. And because of that, it's actually very inefficient. And so what we do and what we encourage our customers to do is create discrete models that are highly performant within a specific domain. And when they do that, they're able to run those in more environments. And so that might take a little bit more homework up front to be able to get that spun up. But what you'll find is when you're able to capture the knowledge you need within a smaller model, that allows you to put it on anything you want. And then also you can have it where you're routing to the proper knowledge based on the right question. And so if you have 4 different knowledge domains, you can have it choose the right model and correspond and change the model it's running with. And in that sense, it would have the knowledge you need, but without compromising the broader sense. Yeah. Any more? Yeah. 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 So it was a little bit of both. So the question was the gentleman that spun out the fire algorithm model. How did he do that? So what we did is, we ran into the problem that when we started the company, we were good at AI, right? We could train models, we could do that, but then we ran into the problem of how do you actually put the thing into the environment that you do. So then we went through the exercise of hiring software engineers. And then it was like, okay, now you have to program to be able to do it. And so then we went through the exercise of creating an application layer that allowed you to interact with the back end without having the AI expertise. And so we provided him the platform, and what the platform allowed him to do was connect to his computers in his environment, so he was able to integrate with his existing compute. He integrated with the cameras that he already had in his environment, and then all he had to do was capture a data stream and train that model. And so when the right person is equipped with the right tools and they're familiar with the problems, they're able to solve a lot of different problems. And then more broadly speaking, we do have a service arm that can do basic consulting to get people spun up on it. But that's not a traditional pattern, but we do it. Yeah. All right. All right, well, thank you guys for coming.